This video is to help you to review for the Unit 7 quiz. Remember, these will be sample questions as to what you'd see on the quiz. In addition to that, you may see some of these types of questions also on the test. So the first question has to do with, are two shapes similar? In this case, are these two rectangles similar, and why? So for similarity in math, we need three different things to occur. First of all, the two shapes need to look similar. You aren't going to say that a triangle is similar to a rectangle, for example. But that's just the first step. And of course, these two shapes do look similar. They're both rectangles. The second step is that corresponding angles need to be congruent. What we mean by there is that this angle, for example, would correspond to this angle. It's the upper left angle of the rectangle. This angle here would correspond to this one over here, the upper right hand one, and so forth with these bottom two as well. And we do know that those corresponding angles, green to green, orange to orange, and so on, are congruent because in a rectangle, all angles are 90 degrees. So we've now met the second criteria for similarity. First is that they look the same. Second is that corresponding angles are congruent. The third criteria is that the corresponding sides need to be multiplied by the same scale factor. So what we mean by for that is 30 and 20 are corresponding sides. They're both the length of the rectangle. And 9 and 6 are also corresponding sides. And that is because, again, they are the width of the rectangles. So what we're looking for is to see if the multiplier or scale factor that gets us from 30 to 20 is the same multiplier or scale factor that gets us from 9 to 6. All right, and as you can tell, we are making these side lengths smaller. The rectangle has become smaller. So we know this multiplier or scale factor is less than 1. If you multiply 30 by 1, you'd get 30. Multiply 9 by 1, you'd get 9. The rectangle would be the same size. If you multiply by something bigger than 1, you'd get a longer length and a longer width. So in this case, we can tell that the multiplier is less than 1. And specifically, if you remember, the way that we find that multiplier is to look at what the new value is, the new length, the new width, and divide it by the original. So to find a multiplier or a scale factor, get you from a shape to its possibly similar shape or corresponding shape, you take the new and divide by the original. So what that means is our new is 20 here, and our original was 30. So 20 over 30 would be how we would find that multiplier or scale factor. And then in the width, the new is 6, and the original was 9. So 6 over 9. So the question is, are these the same? Is 20 over 30 the same as 6 over 9? If they are, if that multiplier or scale factor is the same, then that would meet the third criteria for similarity. And we can tell that these are the same. If we simplify 20 over 30, you could divide both of them by 10 and you get 2/3. It's kind of an ugly looking 2, but hopefully you can read it. And if we simplify 6/9, we can divide them both by 3, and that is also 2/3. So that means the multiplier that gets us from 30 to 20 is 2/3. And the multiplier, again, a bit messy, sorry, that gets us from 9 to 6 is also 2/3. And if those corresponding sides are multiplied by the same scale factor or multiplier to get us from one to the other, then that satisfies the third criteria for similarity. So we would say yes, because number 1, they look the same. So the rectangles look the same. Number 2, corresponding angles are congruent. And number 3, the corresponding sides are multiplied by the same scale factor. In this case, the scale factor being 2/3. Now, if you want time to copy this, because remember all of these quiz review and test review questions you can put into your workbook. If you want time to copy this, you can always pause the video and take the time you need to copy it down and use those notes on your quiz and test. So again, if it meets all 3 criteria, we'd say they're similar. If it doesn't meet, if there's even one criteria it does not meet, then we would say that they are not similar. The second idea for the quiz review is that we are given, a length, a diagram, and we're asked to solve for x. So what we can see is that on this length, we have x plus the same value of x, otherwise we would not use the same variable. So x plus x again, plus 12 has to equal a total length of 48. Now, how you choose to solve that at this point is up to you. But again, we would say x plus 12 equals 48. You could do it in a more formal format like I have shown here, which is that when you combine the x plus the x, we get 2x. So we have 2x plus 12 equals 48. And the reason I put the initials or the abbreviation CLT behind here is that stands for combining like terms. When you combine a variable term x with another variable term of x, you're going to get 2x. That's considered combining like terms. If we would combine two constants, that would also be combining like terms. Then we're going to move on to the next step. Again, you do not have to do it in this formal of a saying or formal of a format, but the idea is that we would want to take away 12 from both lengths. So we would take away 12 from both of these parts. If we take away 12 here, then we're left with just 2x. And if we take away 12 here, because again, if you're going to do it to the first diagram, you're going to do it to the second. If you do it to one side, you got to do it to the other. We're going to get 36 because the 48 minus that 12 means that this new length, I'm going to try to do it with a color right here, this new length right here would be 36. So if these two x's together equal 36, and we know they have to equal each other, you could divide both of them by 2 to give you a value of 18. Again, keep in mind, though, you do not need to write it in this formal of a format. We will do more of that in 7th grade, but right now we're looking for you to be able to figure out what the x value has to be based on the diagram, and you can do that in any way. Another type of problem, again, sort of some spiraling from last unit as well, is to divide 1 3/4 by 2/3. Remember, this is representing a mixed number. So this is 1 3/4 divided by 2/3. So we could rewrite it in this way. Remember that you're allowed to use scratch paper on your quizzes and tests as well. So your first step would probably be to go ahead and rewrite it this way. Then remember, we want to change these both so that they're both fractions, because right now this first one is a mixed number. So to change 1 3/4 to a fraction, we know that it is an algorithm of the denominator, 4, times the whole number 1, plus the numerator 3 over the original denominator. In other words, 4 times 1 is 4, plus 3 is 7, so we'd get 7 over 4, divided by 2/3. So now we've rewritten this as a fraction divided by a fraction. Then we would use our keep, change, flip method, which would be that we keep the 7 over 4, keep that as is. We would change our division sign to multiplication, and we would flip our second fraction. So instead of 2/3, we're using its reciprocal, which is 3/2, 3 over 2. So we'd have 7/4 divided by 2/3 becoming 7/4 times 3/2. Now remember, you can simplify before you multiply, or just multiply then simplify. In this case, actually nothing will simplify, so you just multiply across. 7 times 3 is 21, 4 times 2 is 8, so you get 21/8. And I don't have it shown off to the side here, but you could, on your scratch paper, realize that to change that improper fraction to a mixed number, you would take 21 divided by 8. 8 would go into 21 2 whole times, giving us 16. Subtract, you get 5. And this whole number at the top, remember, is always your whole number. And what you get when you subtract is going to be the numerator of your fraction, and the original denominator or the divisor will be the denominator. So 2 5/8 is the mixed number format for 21/8. Then you're going to be asked to multiply a mixed number by a fraction. So 3 1/4 by 8/9. So again, I rewrote it this way. On a keyboard, it would appear this way, but of course, we didn't have to do it with a computer keyboard. We write it this way. So 3 1/4 times 8/9. And again, you're going to want to change that 3 1/4 to a improper fraction before we can multiply. So 4 times 3 is 12, plus 1 is 13. So we get 13/4 times 8/9. Now we want to be careful. This is not division, so we're not doing a keep, change, flip. Instead, we're just multiplying as we see it. You could again simplify before you multiply. So 4 divided by 4 is 1. 8 divided by 4 is 2. All right, and then you can multiply across. The reason I did that is because then I get smaller numbers to work with. So 13 times 2, of course, is 26. 1 times 9 is 9. And again, you would change that to a mixed number. So 26 divided by 9. 9 goes into 26 2 whole times. That'll be your whole number, giving you 18. And subtract, you get 8. So that would become the mixed number of 2 8/9. Another type of question that'll be on the upcoming quiz is something like, what is 1/8 of 32? Now we know, of course, in math that of means multiply. So we're taking 1/8 times 32. So one way you could do it is to make this 1/8 times 32 over 1, because a whole number we know can always be put over a denominator of 1. Again, you could simplify before you multiply. 8 divided by 8 is 1. 32 divided by 8 is 4. So you get 1 times 4 over 4 times 1. So you would get an answer of 4. Again, you could also, reason it out. 1/8 of 32 would be the same as 32 divided by 8, which is 4. You could also draw a sketch, take 32 and of something like circles and break them into, 8 groups. And how much is in each group? 4. So those would be different ways of doing it. Now, the next type of question specifically has to do with what we did later in this unit, where we are given an algebra tile picture and we're asked to write down the steps. So remember, when you see this tile, this is the X tile, which means that we are picking a number or choosing a number. It's our unknown number. So when you see the X tile, your step for that would be pick a number. Then what we want to do is say, well, what did we do to get from this step to this step? Well, we still have our X tile, but now what have we done? We've added 3. All right. And then what did we do to get from this step to this step? All right, when we look at this picture, which had 1 X tile and 3 unit tiles, now we've got 2 rows of 1 X tile and 3 unit tiles. So we've multiplied by 2, or you could say double it. So that's what we're looking for there, is recognizing what the steps would be in terms of wording that get us these algebra tile pictures. And this would be considered the first, then the second, and then the third in terms of the algebra tile picture. So pick a number, and then we added 3, and then we multiplied by 2. We also want to know some of the math terminology that came up in this unit. So we have to be able to identify the coefficient and the constant in a term. Remember that the coefficient is always the multiplier of the variable. So the coefficient would be the 13. All right, whatever the multiplier is on the variable, whatever the number in front of the variable, that is going to be our coefficient. Remember, a constant means that it does not change, and that means it's a number, not a variable term. So the constant would be the 5, because that is the term that is not changing, just the 5. Another thing you'll have to be able to do on this upcoming quiz is to rewrite using the distributive property. Now, remember, you can do this in more than one way. One way you could do it is you could make yourself an algebra tile picture. If you had 4x plus 6, and I'll make this a really quick sketch, it won't be very impressive, but yours doesn't have to be on your scratch paper either. But if we had 4x plus 6, all right, these are representing my X tiles, these are representing my unit tiles. and we wanted 3 groups of that, because remember the 3 in front means we're multiplying by 3. The question would be, what would we have altogether? All right, so that would be one way to do it. Another way you could do it is you could say, all right, I'm going to take and this 3 and multiply it by the 4x. And if I take 3 times 4x, that's going to give me 12x. And then I'm also going to take that 3, distribute it to the 6. I'm going to multiply it by the 6. So the plus sign, of course, comes along, and 3 times 6 would be 18. So what we're looking for an answer is this, but whether you choose to do it by sort of thinking of it in terms of algebra tile, or whether you choose to do it in a little more theoretical way, like just showing, okay, I know I need to multiply 3 by every value inside the parentheses, so 3 times 4x is 12x, plus 3 times 6 is 18. It doesn't matter, whatever way works for you to successfully get the right term there. All right, we'll also have to think of going backwards on that. So again, that came up in this unit as well. So the idea is if we had 12x plus 18 and we were putting it in factored form, what would we have? Again, if you just do a quick sketch for yourself, you're looking at 12 x tiles, which would be the long, skinny rectangles. Again, I realize these are not rectangles, but hopefully it'll help us give it the idea. So if we have 12 x tiles, and then if we had 18 of the unit tiles, okay, so I'm just going to put those off here for now. Again, this is not very good looking algebra tiles, but hopefully it gives you the right idea. And the idea is if we want to put it in factored form, remember that's considered the opposite of the distributive property form. We're trying to see what is the largest amount of groups we can make. All right. So what we're saying to ourselves is when you look at the 12 x's and the 18, what is the largest amount of groups we can make so that we have the same number of x tiles in each group and the same number of unit tiles in each group. And hopefully you would find that by looking at the 12 and 18 and thinking about the greatest common factors of those. So the largest factor that they both have in common is 6. Both 12 and 18 are divisible by 6. So 6 would be the largest number of groups we could make. So the question is, if we take these 12x and divide them into 6 groups, what will be in each group? All right, well, if we have 12 x tiles and we divide into 6 groups, each group will contain 2 of those x tiles. And then if we take our 18 unit tiles, which again, those are really pitiful looking unit tiles, but if we take our 18 unit tiles and we divide those into 6 groups, because again, they're going to be matched up with some of the x tiles. Each group's going to contain some x tiles and some unit tiles. So we make 6 groups of those, what will be in each group? And of course, 18 divided by 6 means each group would contain 3 unit tiles. So the idea is if we had 12x plus 18, what is the largest number of groups we could make that contain x tiles and unit tiles and evenly divide them up? And that would be 6. And what would be in each group would be 2 of the x tiles plus 3 of the unit tiles. And if you wanted to in your picture, you could kind of draw and sketch out 2 x tiles plus 3 unit tiles and see that, again, yes, if you had 6 groups and each group contained 2 x tiles plus 3 unit tiles, that would be the same as a total of 12x plus 18. So we consider that factored form. The next question sounds rather confusing, but it's actually very straightforward, which is the difference between a numerical expression or an algebraic variable expression. First of all, notice how the word numerical basically contains the word number in it. The numerical expression means it's only numbers. So like 4 plus 3 would be a numerical expression, just contains numbers. In contrast, an algebraic or variable expression means it has to contain somewhere in it a variable. And if you look at 3x plus 12, there's obviously a variable term in there, and that's the x. So this would be an example of an algebraic or variable expression. Again, an example of a numerical expression only contains numbers. Algebraic or variable expression contains at least one variable term, which this does. And then in contrast to that, if you look at the next question, is 3 plus 12 a numerical expression or an algebraic variable expression? Well, 3 plus 12 only contains numbers. There's no variable in sight. So that would be an example of a numerical expression. Again, numerical means numbers, just numbers. Another type of question that will be on the upcoming quiz would be something like this. What would be the algebraic expressions for these steps? So if we had the step, pick a number, the next step being add 6, the next step being multiply by 3, and the last step being add 2, what would be the algebraic expressions for those? Now, it does not say that you need to use your algebra tiles, but again, if that would be helpful to you, you're welcome to do so. Again, keep in mind that they don't have to be drawn very, perfectly by any means. Just a quick sketch for yourself, that would be helpful. So pick a number. When we say pick a number, we know that we're just going to have an x, all right? That's an algebraic expression. It just has the x term, okay? Now, if we add 6 to that, what would be the new algebraic expression? Well, we had pick a number, now we're adding 6, so it's now going to be x plus 6. All right. And again, if you wanted to draw that in terms of algebra tiles, this would be your x, and then this would be your x plus 2, 3, 4, 5, 6. All right. Again, certainly not drawn very nicely, but hopefully gives you the idea. And then when you multiply by 3, it means that the next one has to have 3 groups of that. So 3 groups of x plus 6. And I'll show you where that, sketch, even though it might be a bit rough looking, will come in handy, because hopefully we all see that this would be 3 groups of x plus 6. But you can also think of that then as 3x plus 18, because a total of 3x, a total of 18 unit tiles. So again, even though this is not drawn very nicely, it does help us to see that we have 3x plus 18 all together. Again, you could also have seen that by recognizing that that's the distributive property. The 3 distributed to the x, 3 groups of x, would be the 3x. And then the 3 distributed to the 6, 3 groups of 6 would be 18. That comes in handy because now for this next step, we're supposed to add 2. Well, in order to add 2, it would be probably easiest to do it from the total. But I would take it either way. So you could think of this as 3x, 3 times the quantity, I should say, x plus 6, and then plus 2 added to that. Or, again, this is probably the more straightforward way. If we have the 3x plus 18 and we add 2 more unit tiles, that'd be the same as 3x plus 20. So I'll make a quick sketch of that, even though, again, it won't look too lovely. But we'd have our 3x, we had our 18. And now we're just adding 2 more unit tiles. So for the algebraic expression, it would be x, which again is this sketch, but you did not have to draw it. Then x plus 6, again, you did not have to draw or do it with algebra tiles. Hopefully this just helps you see it a little better. And then that's 3 groups of x plus 6, 3 rows I made. And then when you add the 2, that's here, 3 groups of x plus 6 plus 2 more, or in other words, 3x plus 20. Another type of problem that'll be on your quiz would be this. What is the area of a triangle if the base is 10 and it has a perpendicular height of 4? And again, if I just ask for the numerical answer, it means you do not have to worry about a label. I'm just looking for the number. So this is, again, a review. We want to continue to review part of what this curriculum does in terms of spiraling. Area of a triangle. All right, comes up in our homework many times. And again, we want to have it come up in our quizzes as well to make sure we remember those concepts. So you should have in your workbook already that the area of a triangle formula is base times height divided by 2. In this case, we are told that the base is 10 and the perpendicular height is 4. So that'd be 10 times 4 divided by 2. And 10 times 4, of course, is 40. Divided by 2 would be 20. If we were asked for a label, it'd be 20 square units because area is always square units. But since they said we did not need to include the label, they just wanted the numerical answer, means they just wanted the 20. And then what's the area of a parallelogram if the base is 10 and the perpendicular height is 4? So again, area of a parallelogram is a concept we've covered before. That is found by taking the base times the perpendicular height. In this case, the base is 10, perpendicular height is 4. So it would be 10 times the 4, or 40. Again, we did not have to include the label, it said. And area of a trapezoid is another one that we've been working with. Remember, a trapezoid is going to have two bases, a top and a bottom base. So in this case, it's 6 and 10. And we're going to want to use its perpendicular height as part of the formula as well. So we know the area of a trapezoid is base 1 plus base 2 in parentheses, because that sum has to be done first, then divided by 2 times height, or times height divided by 2. These last two steps can be switched around. So we're going to go ahead and put that into our formula. Base 1 is 6, we're told. Base 2 is 10. Then divide by 2 times 4. Again, I'm getting those values from up here. 6 plus 10, of course, is 16. 16 divided by 2 is 8. 8 times 4 is 32. All right. So we're going to do our parentheses first, 16, then multiply and divide left to right. So 16 divided by 2 is 8. 8 times 4 is 32. Again, our label would have been square units, but we are told we do not need the label, just the numerical answer. So that should be a good review for you of the concepts that will come up on the quiz, and certainly we will expect to see some of those same ideas on the test. Thank you.